So this is also a very important question, which is also related to electrostatic flux, where a cube is taken and at any one corner of this cube a charge plus q is present, due to which we have to find out the electrostatic flux passing through any one phase. Okay, any one phase. So for this, to make its solution, what is the best approach, right? So we know, as per Gauss law or Gauss theorem, the charge should be enclosed within a surface, right? Within a closed surface. Now this charge is open, basically means you can think that on the vertex of that cube a spherical ball is present, and only of that spherical ball this portion is only within the cube and remaining portion are outside the cube, right? So this is not completely closed. So to close it completely, what is the approach? Approach is we have to consider a lot of cubes at first, like this. We are considering total 4 cubes. You can see that including this red cube, total 4 cubes are there, right? This one, and this one. These are the 4 cubes. Now of that charge, means if you consider a sphere like shape of that charge, then of that charge only lower portion or lower hemisphere is closed. Now for the upper hemisphere we need another 4 cubes, right, above it. So total 8 cubes are required. Total how many cubes? 8 cubes are required to close that charge, right? So through that 8 cubes, total amount of flux passing will be q by epsilon naught as per Gauss theorem, because now by using this 8 number of cubes the charge is totally enclosed, right? So what is the amount of flux passing through a single cube? That is, by unitary method it will be q by 8 epsilon naught, right? Now your answer, you are thinking that now it is very simple to calculate, because in one cube we know that total 6 number of faces are there, right? In one cube how many faces? Total 6 faces are there, and if through one cube this much amount of flux is passing, then 6 faces we can calculate, and then from that we can calculate through one phase. But it is not that much simple. Why? Because you can see, just think that this is not a charged particle. At first just think that this is not a charged particle, but a bulb is there. Okay, only a bulb is placed there. What will happen? The light coming out from that bulb will basically glow this surface and the lower surface, but light from that bulb will not fall on this surface, right? Because the lights will come parallel to this surface. And we know that electrostatic flux is what? Is the perpendicular section, right? If this one is the flux, then that flux should cut the plane. If this is the plane and parallel to this plane if flux is passing, then net amount of flux passing through this surface will be 0, right? So only calculatable part of the flux will be due to this one and the lower surface, right? So only 3 phases are effective, because if this is the charge placed here, so this through this surface no amount of flux is passing perpendicularly, or even no amount of flux is passing directly, all will be parallel to the surface. Similarly, if you consider this case, for this surface also will be parallel For this surface, this will also be parallel. Only 3 means this lower one, this side and this side will be the effective 3 surfaces or effective 3 faces. So through 3 faces, q by epsilon 8 epsilon naught amount of flux is passing. Means 1 cube is equivalent to 3 faces here. Okay, so through one phase, our question was through one phase how many flux will pass. That will be 1 by 3 into q by 8 epsilon naught. So answer is q by 24 epsilon naught. This is the correct answer. Through one phase, this much amount of flux will pass. Okay, so I hope this is clear up to you. If you have any doubt, then obviously leave a comment in the comment section. Thank you.